as well as evaluating a function at a given point. So the function we have is this one. Let's take the function that we have, which we want to find the domain and the range. So the function we have is still this one. Now to find the domain, like in the previous video, we are going to equate what is inside the square root there to 0 by using the sign greater than or equal to. So we have this greater than or equal to 0. Now here you can solve for x values or x value using factorization method. You can find the sum and the product. Now if you do that, whatever method you choose to use here, you are going to get positive 6x minus 2x minus 12. So I have used factorization method here. You can use any method and see what you are going to get. At the end of it all, the value of x or the values of x should be the same. So using factorization method, you are going to get x minus 2. So if you factorize, you are going to get x minus 2. Okay. Should I show you this? Or anyway, let me show you here. So if you do that, you are going to get x this side, open bracket, you are going to get x plus 6, right, minus 2x plus 6. Okay, this should be greater than or equal to 0 again. So this, we're going to have x minus 2, again, open, we're going to have x plus 6. This should be greater than or equal to 0. Okay, so this is a bracket. Okay, so this means x is equal to, x is greater than or equal to positive 2, right? Or x is greater than or equal to negative 6. So these are critical values that we have for x. Now, to find the domain, you can draw a line. Okay, let me draw a nice one. You can draw a straight line, which can help you find your domain. And I'll show you how to use this line. So what you can do here, your critical values, okay, the critical values you have negative 6 and positive 2. So choose one point here, and this is your limit. So you have negative 6, right? And this side you have positive 2. So in between here, you have some numbers or some values, right? And going this side, you have positive values greater than 2, and here you have positive values greater than or less than negative 6. So this side you have negative 7, you can have negative 8, right? And here you have positive 3, you can have positive 4, and here we have those numbers in between. Okay. So the best way you can do here, you can try to plug in the values, okay, the values between negative 6 and 2, and see if your function will still be defined. Okay, so you can try plug in there negative 5, plug in maybe negative 1, plug in 0, and see if your function will be defined. You can also do the same. You can plug in your function negative 7. In fact, since the values says x is greater than or equal to 2, start with negative 6. Plug in negative 6 and see if your function will still be defined, and any other numbers going this side. And here you can plug in starting from 2 in your function, okay, and see if your function will still be defined. As if you do that, you're going to find that at this point here, your function is not defined. So from this point, okay, from the numbers starting from -5, or let me say excluding -6, okay, and excluding +2, the values here will make your function not to be defined. Okay, so here your function is not defined. You can try that out, it's not hard. Okay, and then if you plug in any number in that function, okay, in this function which you have here, okay, try to plug in 2, your function will be defined. Try 3, your function will still be defined. Try 4, your function will still be defined. So this side, your function is defined. In fact, let me use a different color so that I show you what that means. So this side, your function will be defined, and also every number from this side starting from -6, your function is still going to be defined. So our domain in this case can be, so we know that this side we have x values, okay, which are less than or equal to -6. Our function is defined this side, and this side we have the values x greater than, right, or equal to 2. Our function is defined. But here, all the values which are in between here, the function is not defined, right? Okay, so the domain then is going to be domain is equal to, okay, x such that x, okay, is greater than, okay, so x is okay, let's start with x should be less than or equal to 6, so it should start from 6, or x should be greater than or equal to 2, but x will still belong to the set of real numbers. So at this point, our function, this set, okay, this domain that we have will define our function. Okay, all right. Now we can go ahead and solve for the range. Okay, so this was our a. Now we can solve for the range. We are still on a. Now the range. Okay, so we want the range. So how do we find the range for this function? Okay, because we have the domains, okay, we have domain here, so we can start plugging in these numbers and see what we are going to be getting. For example, since the domain only excludes numbers between -6 and -2, while not including -6 and +2, that means if we plug in, okay, let's try plug in our function there, x with 0. So when x is equal to -6, we are going to get fx, okay, fx will be 0. You can check that fx is going to be 0. If you plug in x is equal to +2, your function, that is fx, is going to be equal to 0 as well. Now try there, if you plug in, let's say 3, okay, if x is equal to 3, your function, okay, that is f3, your function, okay, I'm using the general term here, your function, if x is equal to 3, is going to be 3, and it will continue like that, okay, and all the values that you are going to be getting here will be positive values. So what does this mean? This means, okay, this means your range is going to be all positive numbers. So that means your range is going to be fx fx such that fx or y value or the y values will be greater than or equal to 0. So the solutions that you'll be getting for this function for every domain that you have defined will start from 0 to positive infinity. So the other way you can write this range, you can write it as including 0, so 0 is included, to positive infinity. Okay, so like this. So this is the range for this